Hey there. We are going to be going over the ions and charges Nearpod today. In case you missed it in class, this will be a good way for you to review what happened and get a quick version of what we were in class. So I'm starting here. The link is in the week 9 folder. If you go down to ions and charges Nearpod, that will be what I'm going through if you need to follow through it as well at your own pace. I will also post a link to this video in the ions and charges notes as well. So this is the warm-up. The first question was, which of the following is a halogen? If you look at this periodic table, the halogens are the light purple column right here. So that would be anything in here, what you're looking for. So based on our answers, iodine is the only one that fits. Iodine is the only one in that column. Next up, it's saying the next two questions have to do with nitrogen. And I'm asking how many energy levels or rings does it have? And then 3 is going to ask how many valence electrons. So I'm going to answer both of those at the same time here. So let me pull up my coloring. So if you look, you have nitrogen right here. All right. And nitrogen is located on the right side of the periodic table. And we have taught in this class that how we find that is based on its row. So the first one is its row. So you can see that nitrogen is right here. It's in the second row. So that means it's going to have 2 rings to it. So it's the first row, and this is the second row. That means if you draw it, it would have 1, 2 energy levels to it. And then next, I have to ask you about the valence electrons, which are based on the column. And this is in column 15. And I remember telling you guys that what you do is you take away the 1, and that will leave you with 5. So the correct answer is there are 2 energy levels, and there are 5 valence electrons. 2, and then 5. And those are all correct. All right, so I'll let you guys answer this one on your own. How comfortable are you with atoms in the periodic table? This is just kind of a diagnostic tool for me to see where you're at and how fast I'm going is if it's appropriate or not. So go ahead and answer that on your own. All right. So we're going to be talking about ions today. Ions, we have mentioned this before in class, so it shouldn't be a totally new concept to you. An ion is an atom or a group of atoms that has an electrical charge, either positive or negative. So atoms have equal numbers of protons and electrons. You can find the number of protons based on the periodic table. You can look at the atomic number. The atomic number will tell you the number of protons. Then that will also tell you the number of electrons for now. We're going to learn today that these atoms swap electrons back and forth in order to form bonds. So atoms with an incomplete shells are unstable. They want to become like the noble gases, which is the far right column on the periodic table. They want to become like them and have a full valence shell. So when this happens, they trade electrons back and forth, either by sharing them or taking them, and those form ions. So this is the first part of your notes. An ion either gains or loses electrons. An ion either gains or loses electrons. And again, just to show you where you should be. So the bold letters are the ones that you write in. So an atoms which either gain or lose electrons, and you can see that it matches right here. So they do this to become more stable. A stable atom will have 8 valence electrons in its outer shell. So again, atoms have 8 valence electrons in order to become stable. So that stability is based on the octet rule. If you think about other words that start with oct, like octopus or octagon, those are all words that start with OCT, and that means 8. So that's an easy way to remember that atoms will either gain or lose electrons to get full shells of 8. So what you should be thinking is, that's weird. Why would you lose, how would you lose electrons and get to 8? We're going to get into that in a minute. So you should be writing this down in your notes. So if I'm moving too fast, make sure you pause this, type it in, and then you can resume the video for a little bit better viewing. So here's an example. Fluorine is atomic number 9, so therefore it'll have 9 protons. If it has 9 protons, like we talked about earlier, it will also have 9 electrons. Remember, these balance out. If you add the protons and subtract the electrons, you're going to get a net charge of 0, which is the charge. And if you look here, that's exactly what's going on. You got 2, 4, 6, 8, 9 electrons. That balances. But fluorine wants to gain an electron to have that full shell of 8 that we talked about in the octet rule. So gain to 8. So it really wants to steal an electron, so that's what's going to do. So it will take an electron from another atom. Fluorine is one of the most reactive elements on the periodic table, so it's going to be very aggressive in taking this electron from basically anything. Once it does that, now it's happy and it has that full shell of 8. However, if you look at the ratio of electrons to protons, you have 9 protons and now 10 electrons, which gives you an overall net charge of 1 because you have 1 more electron than proton. So this is where charges come from, is the comparison of protons to electrons and which one is more, and that's the charge. We're going to learn about what charges do later. So in this simulation, you can go ahead and you can, I'm not going to spend a ton of time doing this, but if you're going through this on your own, I encourage you to play with this and make some atoms. And then notice that if I balance, I have lithium, I have 3 protons. If I balance it, I create a neutral atom. And if I look at the charge, it's 0. But for example, in this one, lithium would want to give away an electron. So if I give it away and take it away, I create a positive ion. And that's what lithium will become in that situation. So this is a good exercise for you to test out what we were just talking about and get a good feel for it. So when we give or take away electrons, we form these ions, and a positive ion is called a cation. So this is one where they will lose an electron in order to get to 8. So let me show you an example of that first, and I'll go back to that slide. So here you have sodium. Sodium has 11 protons, but 1 electron has 11 electrons, but only 1 electron in its outer shell. This is what I'm talking about when it wants to get rid or lose an electron in order to get to the full shell of 8. The last outer shell has 1 electron. If it loses that electron or gives it away, this last shell will dissolve and you'll have a full shell of 8 underneath. And that's what it's trying to do. So what it's going to do is it's going to give away this electron pretty easily and form this stable ion below. So sodium will lose an electron to become positively charged. And that's right here in your notes too. So to look at this, a cation, this is one of your definitions down here, is when an atom loses an electron. This unbalance will cause it to have a positive charge. So this will have more protons than electrons because it gave its electron away. Oppositely, the anion is when an atom becomes negative with its charge because it's taken on more electrons, like the fluorine did. The fluorine took on an electron and became negative because it had more electrons than it did protons. So an atom that is negative will gain electrons or take them. That also fills in your notes. Here's a demo. So the sodium ion is giving away its its electron to fluorine, and this forms a bond. This is called an ionic bond because it makes two ions, the sodium positive and the fluorine negative, and just like a magnet, they attract each other. This is called an ionic bond. So here is going to be a video. I have 2 questions for you. So I'm going to let you watch that on your own. So you can pause the video now and watch this on your own and answer those questions. Just because I'm not going to watch it here because watching a video while watching a video is kind of meta, but also unnecessary. So pause my video now and watch this on the Nearpod. All right, welcome back. You should be on this slide now. And this is an example of an atom, a regular atom in the middle. It gives away an electron, it forms a cation. If it gains an electron, it becomes an anion. So it's a real simple drawing of what's going on. All right. So for this, I'm actually going to switch over to your notes. What I've done is I've broken up this table at the bottom here, right here, into strontium, polonium, and silicon, and I've split that up into 3 separate problems. So you can do those on your own if you would like, but I'm going to fill them in here so it gives you a good idea of what to do on your table. Let me actually zoom in a little bit. Okay. So strontium is right here. So what I'm going to ask you to do is I'm going to ask you to look up the total number of valence electrons. So if I look on a periodic table, here. All right, so this will show you. I encourage you to pull one up in another tab so you can go back and forth. Once I start drawing on the screen, I'm not going to be able to go back and forth because it'll erase whatever I have. So I'm going to stick on one screen. You should go back and forth so you understand where this stuff is. So the 3 atoms we're going to talk about, I'm going to go ahead and circle them here, are strontium, which is right here. It's in the 2nd column. Polonium is right here. It's in the 16th column. And then silicon is right here, and it's in the 14th column. So based on what we've talked about in finding the valence electrons, which is the first thing in each one of these columns, strontium will have 2 right there. Silicon will have 4, because remember, if you have column number, you ignore the 1. And that will give you the amount of valence electrons. So polonium is 16. So if I get rid of it, the 1 in front, it will give me 6. So 2, 4, and 6 valence electrons is what we're going to be looking at when we go through this table. So we're going to start with strontium has 2. So this will give, will this give or take? So what you're going to do is you're going to take the valence electron number here, and you're going to put, pretend to mark it on your line up there. You can do this on the Nearpod if you need to draw it out. So you can draw what I'm drawing on the Nearpod slide if you need a visual. So I'm going to go ahead and put an X on the 2. So what I'm going to show you here is that if it is closer to either end, that atom will take that route in order to get there. So think of it like a journey. All right, this has 2 valence electrons. It's closer to emptying the shell. If it was over on this side, it's closer to filling the shell. So it's going to take the quickest path to either side. So this one will give or take. So strontium has 2 electrons. That's closer to the 0, so it's going to fall in this give category. So it's going to give electrons away. How many? Whatever number is there. So it's going to give away 1, 2 to get to 0. Remember, it wants to get to 0. So you're going to put 2 here. So think of this too. If you're giving something away, if you're donating, that's a good thing. That makes people happy. If you're taking something away from somebody, it's sad. That's negative. So what is the new charge? It'll be plus whatever you gave or take. So this one gave 2 away, so it's going to be plus 2. And this will be a cation because cations have a positive charge. All right, next up we have polonium. Polonium had 6 valence electrons, so I'm going to put that one here. So I'm going to put a 6. Since it's closer to 8, it's going to, look, it's in the take side down here, so it's going to take. All right, how many? How many does it need to take in order to get to this 8 mark over here? So 6 would be 7 and 8. So it means 2 to get there. And then you're going to combine what it took with the symbol. So remember, takes are negative, so it's going to be a minus 2. And negative ions are called anions. Finally, we're going to do silicon, which is 4 valence electrons. So that lands us right in the middle. All right, because this one you should be, hopefully we're curious about when you're looking at the periodic table. It's in the 14th column. 4 is right in the middle between 8 and 0. So it's not easier to go to one side or the other. And that's true. So what's going to happen with anything in that column? So carbon, silicon, germanium, tin, lead, those all give or take electrons depending on what situation they're in. So if carbon is in a situation with an atom that wants to give away electrons, then it will become an anion and take those electrons. If carbon is in a bond with something that wants to take electrons really bad, like fluorine did, then it's going to give away its electrons. So it really depends on what it bonds with, and that's kind of a whole complicated section of chemistry that you could do a whole course on. But I'm just going to show you what the trend on the periodic table is for these ones. So for give or take, it's going to do both, like I said, depending on what situation it's in. Will it give or take, and how many? It's going to either give or take 4. And since it can do both, it's going to be a plus and a minus. Plus/minus 4. And it can either be a cation or an anion. So this takes us to the end of our notes. Hopefully this was helpful. If you have any questions about what to do and how to do this, please reach out to me on Schoology or send me an email and let me know. And don't forget to submit these notes on Schoology. So you should have all this stuff filled in by now and submit it on Schoology.